Alright, welcome to Programming 11. This is the first tutorial for our Pacman game design project using Visual Studio 2010 Express. Today we're going to give you just a brief overview of the project and how to get started on it. Some of the things you need to do before you start writing any code. And then we're going to give you a quick demo of what the game will look like. And then of course we're going to get started on the very first part of creating your project and the global variables you're going to need to declare. One of the things you're going to need before you even get up and running on this project is you're going to need a list of files. You can Google these. I don't expect you to, this is not a graphic design course, so I don't really expect you to use Photoshop or anything. If you can use it on your own, that's great. If not, it's not a big deal. A lot of these images are available on the internet. So what I'll do is I'll just give you a quick idea of what the images look like. These are our image files here. And we actually have these sort of yellowy ones obviously are our Pacman. We've got a base Pacman image, which I've called b.png, and then we've got an open mouth image depending on which direction he's facing. So if he's going down, it's d.ping with the mouth facing downward, l.ping for left, r.ping for right, and u.ping for going up. I also have two different images. I'm only going to put one ghost in my demo. We've got inky.png and we've got inky vulnerable png. This is the image that we display obviously after the player has gobbled up a power pellet and Inky is vulnerable. And then I also have a bunch of sound files. I've got the beginning music file, Pacman chomp, that's when he's eating one of the regular dots, Pacman death sound, eating the fruit sound, and so on all the way through. Again, these can be Googled. The only adjustment that I made was I used instead of using a transparent background, Visual Basic doesn't really like that too much. I ended up using a black background, and I'm going to place the image with the black background on a black background on my form so that this bit here won't be visible. And as Pacman moves towards the dots, you'll barely be able to make out the dots. Now each of these, or make out the black background. Each of these images themselves are 50 pixels by 50 pixels. And that's going to work out real well for us because that's how big we've designed our game board. The first thing I want you to do though, before you even start writing any code, after downloading your images of course, and your sound files, is to create an Excel spreadsheet that looks a bit like this. I'm going to zoom in a bit on this so we can get a better look at it. Alright, so what I've done with this is I've created an Excel spreadsheet that looks a bit like this. This is what my gameplay area is going to look like. I'm creating a relatively small playboard. I'm expecting you to create a much bigger maze for Pacman to go chomping through. But the logic of the setup is going to be pretty much the same as regardless of the size of the board. What we have here though is obviously each of these blue boxes represents the cell walls, the places where, or the maze walls where Pacman can't go through. The white bits represent the passageways where Pacman and the ghost can travel through. And then these guys on the end here, these little ones labeled with a P, that's the secret passage or whatever you want to call it, where Pacman or the ghost heads out one side and back in the other side, or vice versa. Now how we're designing our game board is we're going to create a 50 by 50 tile picture box using the form object picture box, and we're going to place it on the screen for each of these different cells for our wall, which is going to make life really easy, or make life really nice for us, because when we place all these picture boxes for the walls and we don't place picture boxes for the white space, the passageways, it's going to make our life wonderful because we can use picture box collision detection to determine whether Pacman can move into the next cell or not. So again, the blue cells here represent where our game tile, the game walls are going to be in a picture box. The white ones are not. Now the other thing you need to do when you go and design your Excel spreadsheet, you could do this on a sheet of paper as well, is you need to put the numbers across the top and then down the left hand side. Let me move it over just a touch here. The numbers across the top represent our dot left values for each of these picture boxes. So this very first picture box here that we're going to place on the screen is going to have a dot left property of 0, which means it's going to be right up against the left hand side of the form. The next picture box over is going to have a dot left property of 50, and then 100, and then 150, and so on as we work our way across the top. So each of these has a width of 50 pixels, and its dot left property, or if you want to use sort of regular math vocabulary, its dot x value will be listed across the top. its .top value or Y value is listed down the side here. So for any given picture box, you can quickly determine what its .top and .left values are. Simply click on the file, and there's your, in this particular file, click on the cell, and then you can look up top here. Our .left property for this particular cell is 100, and our .top property is also 100. This one is 200 .left and 200 .top. And let's pick one that's not the same here. Let's go right here. This particular picture box will be a 250 .left and a 0 .top. And that's pretty much it. We're going to be adding each of these picture boxes at runtime. I don't want you designing them by dragging picture boxes onto the form. That's just going to be clunky, and it's going to make our code really hard to manage. So we're going to add these at runtime. I'm just going to minimize this now, and I'll show you what the game board looks like. Alright, so here is our playing area. You'll notice I don't have a whole lot on here right now. My game is fully functional. We're going to design this game again by adding each picture box for our walls at runtime. We're not going to do it at design time. So all I have here is I've got a picture box here, and this particular picture box is 50 by 50 pixels by 50 pixels. And that one there is our Pacman. That's where our Pacman's going to start location is going to be. And this other picture box way over here is for our single ghost. So the Pacman is called My Pac, and the ghost is called My Ghost. You're going to wind up, for your games, I've only got a single ghost on mine, but for your games, I'm going to want you to add extra ghosts. I don't want a single ghost. I want you to have at least 2, and preferably 4. And if you really want to do well on the project, you'll have multiple ghosts, each with a slightly different personality on how they, attack Pacman and how they move around the game board. Alright, nonetheless, we got our My Pac there, and we got our My Ghost down there. The only other thing you need to create at design time is 3 different clock values down here. One clock, or one timer I should say, is for our Pacman, and this is going to manipulate the movement of our Pacman. One is for the movement of our ghost, and the other is for the movement of our the timer for our power pellet. So our Pacman move clock, we're going to initialize its enabled property to true right off the bat. So when you create it over here, remember your properties are way down over here. This is our Pacman move clock, and we want to enable it to true right off the bat. That means the timer is going to start ticking immediately as soon as the game launches. We also want to set its interval value to 100, so that means 10 times per second it's going to update our Pacman. And we're going to do the same thing for our ghost move clock, is right down here. Same thing. Ghost move clock is going to be enabled to true right off the bat, and then we're going to set its interval to 100 as well. For our power pellet clock, it's a bit different. We don't want our power pellet clock initialized right away. This is just the thing that will time. Oops, let me move over here. We want to enable it when Pacman eats the power pellet. So it's going to start off as false for enabled. That means it's not going to start off right away, and it will start ticking as soon as he eats the power pellet. And we're going to use the same interval for that one, set to 100. Alright, just give you a quick idea on what the game's going to look like. You won't be able to hear the sound files very well because I've got a set of headphones on, but I assure you I do have the sound effects playing. And hit the play button here. And there's our Pacman. There's our ghost that's chasing me around. I'm going to wait for him to come up here. Oh, he's going through the secret passage. I'm going to wait for him here. And then I'm going to go grab my power pellet, go eat the ghost. And then we finish our game board. Alright, so you probably couldn't hear the sound effects for that, but it's okay. I do have sound effects for when we eat each of the dots, and I do have sound effects for when we eat the fruit and we eat the power pellet, and we also have a sound effect for when the ghost eats Pacman. Since I have this open here, I just wanted to show you quickly. This was our Excel spreadsheet. Remember, each of these were 50 by 50 pixel picture boxes. Well, these are picture boxes here, and they're put so closely together that they sort of overlap a tiny bit, so the user will not be able to see that these are individual items. They just look like solid walls. You can use this technique for any game that you want to create. If you wanted to create a dungeon crawler adventure, you could actually put images in these picture boxes to make them look like brick wall or a forestry or whatever. This technique will work just fine for that. Alright, so that's enough for that. Let's close that off, and let's have a quick peek at our code. Alright, we're not going to get into any of these functions down here today. All we're going to do is we're going to look at our variable declarations. These are our global variables. So we've got our public class main. Obviously, want you to put your programmer's block up top. And then I like to chunk off my variables in sort of sections. So a comment marker here. These are the attributes that describe our Pacman. And of course I have 5 image files for our Pacman. You saw that in the folder. One base image, which is in index 0, and then I've got 4 other images depending on which direction you set it. I also have a variable which I store my Pacman's current direction, so whichever direction he happens to be going. I'm going to need a second variable for direction. I call it next direction, and again it's similar, except we want to store when Pacman changes direction or moves, we want to store where he's going to be next in order to figure out whether it's going to be a collision or not. And then of course I got my Pacman speed. I don't use this a whole lot in the demo. I've only included it here just in case you want to make your game a little bit more, want to expand it a little bit, maybe have parts of the game where Pacman can speed up or slow down or whatever. You can add all kinds of tweaks to it. I have the exact same combination of variables for my ghost. So an array for our images, we've got a direction, an x direction, and a speed variable. And same thing with the speed variable. Our ghost speed doesn't change, but if you wanted to make the ghost move faster, whenever the power pellet gets eaten or something like that, it's up to you. And then I got these other sort of global variables that don't really have anything to do with these other 2 things. I've got a counter that we use for our animation. This just counts our ticks. We've got another array of picture boxes here, and this is for our walls. Once we create them at runtime, we're going to store them in wall. I've got another array for my edibles. That's all the things that Pacman can chow down on. Score is pretty straightforward. Base completion just checks to see whether we've eaten all the dots on the screen. And then our power pellet clock, we're going to use this to count up how long the power pellet's going to be run for. And that is it for this tutorial. In the next tutorial, we're going to show you how to build your form at runtime.